to 0.09, the function is decreasing. Is that supported by the sign of the first derivative?
Yes.
Yes. Now we are ready to draw our conclusions. What type of point is this? What type of point is this? What type of point is this? It's easy if you see negative 2.8, 0.18, the altitude negative 2.8, the altitude 0.18, and the altitude 0.09. What type of point is 1/2, comma, negative 2.8?
A minimum?
Yes, but it's what type?
Absolute.
Yes. What type of point is 1.65, comma, 0.18? Keeping in mind that the derivative changes sign in this way. And you can also see it in my arrows.
The relative max?
Yes, and also?
Absolute?
Yes.
Max?
Yes. Perfect. Last one. What type of point is 4, comma, 0.09?
It's nothing.
Yes. I think we got the picture, and I think we learned a lot so far today, how the first, or what the first derivative is telling us about the function. So let's summarize that because it's crucial moving forward. Okay. F prime of x tells us about the function as follows. Number one, what does it tell us? It gives critical numbers. Number two, it gives max min. Number three, what do you think? What else?
Can I have a hint?
Yes, intervals of
For decrease?
yes, increasing
Yay.
or decreasing. It tells us a lot. It gives us the critical numbers, which may be max min. By studying the sign of the first derivative, we determine whether they are max min. And it also gives us intervals of increasing or decreasing. A lot of information that we did not have before. But now we know about the function, which will help us graph a function. Not enough yet. Okay, I'd like at least to start 4.2. Rolls and mean value theorem. Okay, so let's start with Rolls. Okay, so let's look at a picture, of course, a graph of a function on a closed interval, a comma b. So this is f of x. Rawls said this. Rawls' theorem has three hypotheses. Three hypotheses. Number one, would you agree that this function is continuous on AB?
Yes.
Thank you. Would you agree that this function is definitely differentiable on the open interval AB. It may not be differentiable at this point, we don't care, but is it differentiable everywhere else? No jump, no cusp,
Yes.
no corner, no perfect. Also, notice one thing. I specifically graphed the function in such a way that f of A equals f of B. So that's the third hypothesis. Oh, the function does not have to just have one term. The function can have this. Can have many terms, but at least one. So Rolle's theorem says this. If the function is continuous and differentiable, and it starts at one point and ends at the same point, then by Rolle's theorem, of course, there exists a C in the open interval A comma B such that what has to happen? I already gave you the hint. This must be a turn, at least one. It can be here, or it can be here, or it can have many, but it has to have at least. Then by Rolle's theorem, there exists at least one. So we have another symbol that I never showed you. So there exists at least one C in the open interval. You don't have to put it in, but we know there is at least one such that what? And here's my hint. That's what we mean by turn. Such that
A tangent line of f of A is the same
f
as
of prime of C, f prime of C is, if it's a turn, there is only one possibility.
0?
Exactly. There is only one possibility for a turn. F prime at that point has to be 0. The tangent, the slope of the tangent has to be 0 as we discussed. Awesome. So let's see an example of this. And this is 4.2. Okay, so let's choose. Verify that the function satisfies the three hypotheses of Rolle's theorem, of course, on the given interval. Then find all numbers C that satisfy the conclusion of Rolle's theorem. Ready.
Are we picking one or did you?
It's up to you. Okay, let's start with 9. If you don't want to pick, we can pick the next one. 2x squared minus 4x plus 5. The given interval is -1, 5. Okay. So we cannot find C before we establish the three hypotheses. What type of function is it?
Is it polynomial?
Yes, it is a polynomial function. Is f continuous on -1, 5?
Yes.
Always. Is f differentiable on -1, 5? We never had any problems with polynomials. They are continuous everywhere, no cusp, no corners, no vertical tangents, ever. So yes. Now, I don't know what f of -1 equals to, and I don't know what f of 5 equals to. You know how I like to do it. You don't have to do this, but I have to show it to you. That's the easiest way, I think. But what is easy for some may not be easy for others, so you choose. But I like to put it in. I like to see the function. If I have an error, then it's easier for me to find it. Sometimes I need your help to find my error. That's awesome. That's why I want you to speak up. If you see something, you may be right, I may be wrong. Okay, So we find that f of negative 1 is 11, and f of 5 is 35. So then Rolle's theorem is not applicable. I'm going back and look at my function. I'm also checking if I copied it correctly. 2x squared, yes. Minus 4x plus 5, yes. Okay, I don't know. So let's go back. So 2x squared minus 4x plus 5, yes. I plugged in negative 1. I did, and I got 11. I plugged in 5, and I got 35. And then I will conclude Rolle's theorem is not applicable. Not applicable. Okay, so the function is continuous on this, is differentiable on this, but I got that f of negative 1 is 11 and f of 5 is 35. So 11 does not equal 35, so Rolle's theorem is not applicable. Any questions on this? Again, unless I entered something incorrectly. Oh yeah, I copied negative 1. I copied negative 1, 5, but it's negative 1, 3. And my students are not helping me.
How would we have known that?
No, you wouldn't have. You wouldn't have, but as I said, my computer is so far away from me, sometimes I don't. So my mistake. But this problem is okay, it's not problem 9. Example. It was a very good example, but not problem 9. So now we are going to continue with problem 9. It's a very good example. It's very clear. If these two are not equal, I can continue. But from problem 9, we have f of x equals 2x squared minus 4x plus 5. It was a perfect example. I really needed one like that. But, okay, a and b are copied from the above. So now f of negative 1 and f of 3. If these two are equal to each other, then Rolle's theorem is applicable. Otherwise, it's not. So we are still here. Okay, so I want 3 instead of 5. Okay then, fine. So they're both 11. And then we will say, fine, from A, B, and C, by Rolle's theorem, there exists a C in the open interval negative 1, 3, such that f prime of C is 0. So now we can find C. Can anyone find the derivative for this function for us? F prime of x.
4x minus 4.
Yes, so 4x minus 4. Good. So when we said 4x or 4c minus 1, this is f prime of c. 4c minus 4 equals 0. Then we get that 4c equals 4 and c equals 1. I have to show that this is indeed in the open interval negative 1, 3. And it is. Yes. So please remember, you have to write this on your test, on the next test. You have to show that once you find c, it's included in negative 1, 3 that is given to us. And you have to say, yes, it is. Good. So some mistakes are really helpful. This was a very helpful mistake in me copying 5 instead of 3. Perfect. Now your turn to choose if you want.
Sorry, what is yes c equals 1, and is that?
So
is
we
that
determined
similar? Is that for every-
we determined the c guaranteed by the Rolle's theorem that says that f prime of c is 0. There must be a turn, and there is a turn, and the turn is when x is 1. But you have to show that you checked that the number you obtained is indeed in the interval. Because if you find 5, 5 is not in the interval. If you find -3, -3 is not in the interval. So Rolle's theorem says that there exists at least one number between -1 and 3. You found a number, but you have to show that it's between -1 and 3. And 1 is indeed between -1 and 3.
T equals 1, which exists between -1 and 3. Is
Correct,
that what that
as
says?
guaranteed by Rolle's theorem. Exactly. Perfect. Okay, so let's look at one more and then we'll stop. I do not consider 4.2 finished. I do consider 4.1 finished, and all work has to be finished before Monday class. Please, I'm begging you. I don't mind begging. I perfected the art of begging. If you do that, you will not fall behind and you're not going to be stressed out before a test. Please. I'm begging you to do the work as I asked, please.
Can we do 12 because it is a fraction?
Sure. Number 12 here. So we have 12 f of x equals x plus 1 over x, and the interval is 1/2 comma 2. Perfect. Okay, so number 1, number 2, number 3. Is f of x continuous on 1/2 2? Yeah, this is continuous everywhere, and this is not continuous at 0, but it's continuous everywhere. Yes. Is f of x differentiable on the open interval 1/2? Yes, this is differentiable everywhere. This is differentiable everywhere except at 0, but 0 is not here. Now I have to find f of 1/2, and I have to find f of 2. If I do not get these two to be equal to each other, then I'll say Rolle's theorem is not applicable. If they are equal to each other, then I'll continue. 1/2 plus 2. The first one is 1/2 plus 2. The second one is 2 plus 1/2. They are equal to each other. So then I'll say from 1, 2, and 3, by Rolle's theorem, there exists a c in the open interval 1/2 comma 2, such that f prime of c is 0.
How, sorry, for later equations, how will we tell if something isn't or doesn't have a cusp or something of that sort? Like
Because we know the graph of 1 over x. This is a very important function. We graphed this several times. Please have this in your memory. And we know that x is this function. A sum of differentiable functions will always be differentiable. A sum of continuous functions will always be continuous.
For later, for more complex equations?
It depends. It depends on the function you have. I can't give a recipe. I have to look at the function. Yeah, I'm so sorry. I can't give a recipe before I look at it. So can anyone give us f prime of x? I know we're close. I don't have my cell phone. I don't know what time is it. Yes. Yes. It's 8:10. If you can stay for another minute, okay. If you cannot, you're just gonna look at what we finished. So can anyone give us f prime of x? I can't leave it in the middle.
Can you put f of x back on the screen?
Yes. X plus 1 over x. Yes. So what is the derivative? Anyone?
Negative x plus 1.
So we discussed this a long time ago, and we will never forget 1 over x prime.
Negative x to the negative 2.
1 over x squared. Perfect.
Oh, sorry.
1 minus 1 over x squared, which turns into x squared minus 1 over x squared. So now f prime of c will be c squared minus 1 over c squared equals 0. When is a fraction 0?
When c squared minus 1 is equal to 0.
Very good. And we know there are two solutions here, and the solutions are,
Plus or minus 1.
careful. That's why I asked you to make sure that you always go back to the interval. You have to
I
write
see, just plus 1. Or just 1.
exactly. Only c equals 1 is in the open interval 1/2 comma 2. That's why this is crucial. I can't give full credit if my student does not say, I checked, is this? Because look what happened here. You cannot say that both, although the function can have more than one term, but not in the given interval. So Rolle's theorem only guarantees one that is in the given interval. So we have to make sure that we pay attention to that. Thank you so much for